Hi, everyone. Really great to have this opportunity to talk to you about one of our favorite projects, Data Commons. My name is Priya Ramu, and I am in the partnerships team. I've been here for about 3.5 years and work with various teams in Google Research as well as Data Commons, which sits under an umbrella that we call Technology and Society. And I'll hand it to Dan to introduce himself.
Hey everyone, also been at Google for about 3 years. My name is Dan Noble. I'm an engineer on the Data Commons team, and yeah, really excited to explain a little bit about the project fuel and talk about what we're doing with grounding AI systems and Data Commons. So yeah, and happy to answer any questions you may have along the way.
So to just give you an overview of why Data Commons and what it is about, I think since many of you are from the scientific community, and this might be a familiar problem to you, which is many of the big challenges that we face, whether it's in climate change, lack of access to healthcare, poverty, food insecurity, etc. We know that you need deep holistic insights into data to be able to solve any of these problems. And what is also clear is that none of these areas can be solved by digging into the data that's restricted to that field, but we understand that problems are highly interconnected. And so the challenges therefore become super complex, and you cannot solve any of these big problems that we face with a single data source. And it's a known problem that the data that you need to analyze and derive insights from is extremely fragmented. It comes from various sources, and it's very difficult to wrangle all of this data to make the data, interoperable and to be able to derive useful insights. And so our team built Data Commons, and the mission of Data Commons is essentially to organize all the world's public data and make it universally accessible and useful. And so this is similar to what Google Search does for the information on the web, or how Google Maps helps with navigation. And so at the heart of it, Data Commons is essentially a knowledge graph. So this brings together data from various sources, like I just mentioned, into a common format. And the standard data format that we use is called schema.org. And this may be familiar to you. This is a very commonly used data standard used by hundreds and thousands of websites to index their data and to make the information on their website more easily discoverable. And to make it easy for people to be able to use and analyze data, we've also added a natural language interface on top so that you can ask questions of the data in very simple language. For example, you can ask questions about what might be the relationship between two different variables that you're trying to compare. And another important piece about Data Commons that makes it easy for people to use is that organizations that have their own private data can build their own custom version of Data Commons using our infrastructure. And they are also able to securely join their private data with the enormous amount of public data that has been curated and aggregated on the public website. So the website where we host Data Commons is datacommons.org. We would love for you to check it out. Currently we have data from 120 and more sources. This is all public data that is available on a CC by 4 license. We have about 250 billion plus data points, and also 4 billion and more biomedical data points. And we have been fortunate enough to work with some amazing partners and many of these names may be familiar to you. Our flagship partnership is with the United Nations. So a few years back, we started working closely with the UN, with their UN Stats department. And they wanted to build a custom version of Data Commons using our Data Commons infrastructure. And they pull in data from, most countries of the world every few months. And so it's a lot of data that they deal with. And they were able to bring it together using our infrastructure and make it very easy for people to use their to go to their website and to be able to ask questions in simple English. Some of the other partners that we work with are nonprofits like the One Campaign, Feeding America. We also work with academic institutions like Stanford Institute, and they, for example, in their School of Sustainability, have built a custom version of Data Commons that we'll show you a little bit about later in the slide, in the talk. And then one of the other examples is our nonprofit partner, TechSoup. They're a small nonprofit organization who have built, again, a version of Data Commons that brings together climate data with information on poverty, health, local services, etc., to help people identify communities that are most at risk. And this is down to the census tract level. And so essentially, this enables them to put the power of data into the hands of people who know their communities best and allows them to make better decisions to serve those communities. And as we'll just wanted to show you a small video that talks about how we built Data Commons, and you'll hear from some of the organizations that have used Data Commons.
Every moment around the world, people and organizations are generating data that can be extraordinarily useful, and I think we have to find a way to harness that to solve problems. The challenge has been a lot of these data sets are very fragmented. Most of society's complex challenges don't get solved with a single data source. So this fragmentation gets in the way of being able to use the world's information to actually make a big difference to everybody everywhere.
Google's mission is to organize and make easily accessible all kinds of information. We're doing it now for public data. We've gathered, standardized, and processed data from tens of thousands of tables, from hundreds of reliable global sources, and pulled it into one easily understandable view.
This is the fun part. Now comes AI and natural language processing.
Most people don't think in terms of scatter plots or variables of interest or data points or triplets. They think in terms of the question they want to ask of data.
Now imagine if you could just simply ask the question in ordinary English.
And then you get back these graphs that help get you insights and that let you explore more deeply in sensible ways. That ability to make data accessible and intelligent, pragmatic, practical at the organization level makes Data Commons, I think, an essential tool for organizations as they're doing their work.
Generative AI now powers some of the most important functionality in Data Commons. With large language models, you can ask your questions and start getting answers. Imagine, for example, I'm a climate NGO and I'm trying to understand how access to electricity has changed across countries in Africa. I'd search for it on Data Commons. From these charts, we see that Kenya, Somalia, and Ghana have had some of the greatest increases in access to electricity. I wonder what the impact of this on their greenhouse gas emissions has been. From these charts, we can see that Ghana's greenhouse gas emissions have gone up substantially more than that of Kenya. These observations are the beginning of a journey for us to better understand how we could increase access to things like electricity without proportionately increasing greenhouse gas emissions.
When it comes to actually taking action out of the insights from this data, it's going to take people on the ground. We also have to think about this responsibly. So that's why doing this together and thinking about partnerships, collaborations, I think is so important.
It's these people who have deep domain knowledge, who know what the right questions to ask are, who know what the right solutions to build are.
I At TechSoup, we've been working globally to connect nonprofits to technology for over 30 years. Data is at the heart of what organizations need to be able to make change. So we began working with food banks and food pantries across the United States and Google's Data Commons to build our own instance of Data Commons that pulled together the data points and variables that would be most interesting to these kinds of organizations. One of the big complaints we often hear about small organizations is they don't take risks. And it's hard to take risks if you don't have data because they're operating in the known world, right? The world that they see in their data, which becomes self-reinforcing. Data Commons opens that world up for organizations. It means they can take a risk because they're not taking it blindly.
I would not have ever guessed I would see this in my lifetime, and it's so exciting to be at a time when this is actually possible.
Organizations know the questions they want to ask of data. They have the knowledge that gets at the answers that will be meaningful to them. Data Commons democratizes that. So you just go in and type the question you actually have. That is absolutely game-changing.
Hope that gave you a nice overview of how some of our partners are using Data Commons. It was great to hear from one of our partners, for example, from the One campaign, who have a team of 3 data scientists. And they said that because of this and the tooling that they have, they feel like they're a team of 30, which was absolutely wonderful to hear. So this shows you the custom version of Data Commons that was built by the United Nations, where, as I said previously, they bring in data every few months from all the countries, and you're able to ask questions in natural language, such as, if you want to compare how countries are progressing towards the Sustainable Development Goals, for example, it shows you, it pulls the data from different sources and shows you great visuals of how the countries are performing. And earlier this year, the UN Stats added data from the International Labour Organization as well as UNICEF to their unified data platform. And they're working on bringing all the data from all of their other member organizations as well, so that they have this single unified platform that people can go to query their data. Another example that we wanted to share is how a nonprofit called Feeding America has used Data Commons. So they have created a proprietary number that's called the Meal Gap Index. Essentially, it measures how hungry people are. And they have created a custom version of Data Commons, and they make this information available to organizations for non-commercial use only. So although we've enabled their platform, we don't have access to or use this index because it is made available for non-commercial purposes only. But that is just an example to show that organizations can spin up their own custom version and can decide the access levels and controls that they want to provide to people. So for example, with the Meal Gap Index, and the custom Data Commons, you're able to, for example, try to understand if there is a relationship between, health outcomes and income, for example, and use this as a starting point to do additional research. Is there anything else you'd want to add, Dan?
No, I think that's I think we can jump right into the custom Data Commons part.
Great. So this is this shows you, for example, what it would look like if you were to build your own Data Commons. Essentially, this is built in the secure GCP environment. So Data Commons is built on the Google Cloud Platform components. And so it comes with the privacy and all of the security and other bells and whistles that comes with this platform. And you're able to create your data, bring it to the common schema, and then when you have, when you post queries on the data, the system is able to also simultaneously pull information via APIs from the base, from the public data commons, in order to provide the most up-to-date information and actionable insights. And from here, I'll hand it to Dan to tell you more about what the latest exciting tools that we've built and where we plan to go from here.
Yeah, thank you, Priya. So as Priya mentioned, we spent a lot of time kind of partnering with different agencies like the UN and other federal agencies in different countries, just getting data sets onto data commons and normalized and into the right format and into a common schema. But one of the things that's really front and center right now for Google and probably for a lot of you is AI systems, and how do we make sure that AI systems are telling the truth when we ask questions? We've all had the experience of going to a large language model like ChatGPT or Gemini or Claude and asking a question and just getting a very confident, completely wrong answer back from one of these systems. And you're starting to see a lot more citations in these large language models, and that's where we're starting to help out. So how when you ask a question about public statistics, do we weave into that answer citable, factual data from a system like Data Commons? So I will go over a couple of approaches that we've used to help ground some of these large language models and other AI systems at Google. And again, all of these systems are all this tooling is open source, so it's something that you can run locally and work into your own systems. So the first system I'll talk about is called Data Gemma, and this was an experiment that we ran last year. And so as you all may the AI landscape is changing rapidly with new new models are coming out all the time. New approaches to grounding data are coming out all the time. So this was an approach where we took Gemma, which is an open source Google large language model, sort of like Gemini, and we fine-tuned it, or basically we added our own training to it and added Data Commons data to it during the training. And what this looked like was when you asked a question like, is gender equality improving in Uganda, we fine-tuned the model to take this question and then sort of iteratively ask itself, well, what types of data may answer that question? So gender inequality may be made up of things like pay gap or women in STEM fields or education or cases of sexual violence or any number of other things. And these are all things that Data Commons has specific answers to. So we take this kind of broad question and fan it out into more specific things that were fine-tuned on Data Commons data to steer it in a direction where we thought we would have the answer. And then we're able to reach out to Data Commons, get actual statistics, and then have the large language model, in this case Gemma, kind of roll all of these answers back into a response for the user, and then and then likewise provide citations for it. So for this particular use case that we ran, we found some positive trends, we found some mixed trends, but all of these numbers that were in the response came from our knowledge graph. And another thing that these large models are good at is kind of assessing, like, okay, there's some positive correlations, there's some negative correlations, but we don't want to mislead the user. So in this case, the model said we may actually need a little bit more data here to answer the question. And these kinds of responses can help drive data collection efforts or maybe data coverage efforts. Maybe the data is there and we just don't have it. So so you can use these as indicators to really focus some of the different scientific and research activities around statistical data collection. So that was Data Gemma, and that was one of our big focuses last year. All those models are available on Hugging Face, and a lot of the data sets are available there too, that we used for training the data and for running these models locally. Um, but that approach did have some downsides to it. So, well, I guess it had some pros and cons. So with Data Gemma, once the model was trained, it was really fast. We would ask questions, we would get the answers back from Data Commons, and because it was built into the model, performance was great. But training the model took a really long time, and it was expensive. Also, every time we added new data to Data Commons, we would have to retrain. And every time a new Gemma model came out, we would have to retrain. And also, this was tied specifically to that Gemma model. So we took on a new approach this year, and we're looking at a technology called the Model Context Protocol, which is basically a way for these large language AI models in a standard way to reach out to services and to get grounded information. So really applicable to what we're trying to do with Data Commons. This is a standard put out by Anthropic earlier in the year that Google and other big companies are rallying behind to address this problem. So how does this MCP or Model Context Protocol system work? Well, when a user asks a question to a language model, be it a Google model or an OpenAI model or an Anthropic model, the LLM agent, which understands the MCP protocol, will then reach out to different services to pull in factual information. So there's MCP servers for things like Google Calendar. You can say, hey AI assistant, book me an appointment next week at 2:00 on Tuesday, and it'll do that. But in our case, we're looking at how do we pull in public statistical information. So if a user asks a question like, what's the population of new whales? We'll reach out to Data Commons and get that answer, as opposed to letting the LLM, based on its training data, which may have hallucinations, answer the question. And one thing that's great about MCP is it's not tied to a specific model. So you can use it again with Anthropic, you can use it with Google, you can use it with OpenAI. And in this case, I'll run a quick demo where I'll use Gemini CLI, which is a command line version of Gemini, to answer some questions. So let me just take over presenting real quick. But and just to give a quick preview, you can try this out on your own. You install the Gemini CLI utility to run Gemini on your own laptop, and then you just install the Data Commons extension for Gemini CLI, which will get that hook into our data source. And then I'll just go ahead and ask some questions about health data in Australia. So, okay, yeah. So it's a little bit primitive, but hopefully you can see some of the potential here. So here I'm on my command line. I'm opening up Gemini. I'm connected to the Data Commons service here. So I'll just ask a question. Let me just copy it from the slides. So that's what kind of health data does Data Commons have for Australia and nearby countries? And here, the model is asking for permission to go out and call the Data Commons service, and it's able to call the Data Commons API in the background, and it puts together an assessment for what sort of data we have available. So we have global health data, health equity data, and health expenditure data for Australia and a few nearby countries. So I'll take this one step further and say, well, let's actually pull some of that data back and run some comparisons. So here I'll say, compare life expectancy, economic inequality, and GDP for Australia and BRICS nations, which are Brazil, Russia, India, China, and South Africa. So kind of comparing some economic powers with Australia. And here it's just reaching out again to our APIs, pulling in some data, and then it's letting the LLM, in this case Gemini, summarize and give an assessment back to the user. All right, it's running a bunch of calls here. All right, so here it gave us, it made all those API calls, and it spit out a table comparing life expectancy, Gini index, and GDP in these countries. And then here's a kind of a more exploratory question where I'll say, provide a report on concerning health trends in Australia. And this is really where we can kind of lean on the AI system to be creative and query the database here. Like, I didn't ask the AI agent to query for chronic disease, but it came up with, okay, querying for chronic disease, mental health, and a few other topics. So it's kind of running these queries for anything that has data, that'll pull it back and put together a report. So here we got a quick report on some concerning health trends. So we have some data on suicide mortality rate. We also have some data on non-communicable diseases. So it's really interesting, and you can run these queries a few times, and you may end up getting like slightly different results each time. So it's one of the caveats of using these AI systems to try to really do some prompt engineering and ask your query in a way that is specific enough to get a consistent answer. I'll jump back to the slides now. Yeah, and feel free to ask any questions as we go here too. I just wanted to talk about a few customer use cases here too. So we partnered with the One campaign with Data Commons, and the One campaign is interested in a lot of kind of health data sets, and in this case they're interested in how do they showcase their health financing data sets. So they have an interesting problem where they actually have so many different data sets from so many countries. I think they had in the tens of thousands of data sets related to health financing transactions. And so they had the problem of how do they explain to their users what data is even available for these use cases. So in this case, they we try to present a live demo if I can. I think I may have closed my presentation window, but I'll get it working in a second here. But in this case, they used our MCP server as a way to do exploratory queries. So if a user asks something like, what does domestic spending look like for a certain country, they'd get a similar workflow in the background to what I was showing on the console, where the large language model would ask these kind of exploratory queries, but then put together a kind of well-formatted response back. So it's kind of an interesting use case of stepping outside the kind of traditional AI chat experience and working it more into like a more congruent search experience on their website. All right, looks like we got a question here. There's a real political and data bias on AI.
I don't know if we are equipped to answer that.
Yeah, and I think it does depend on the model. But again, for what it's worth, these model context protocol services, this service that we published, it can plug into any of the AI models, and it is up to the AI model. It does give a lot of rope to the AI model when answering the question. So we'll do our part of if there's public statistical information available for a query related to something the user asked, then we'll pull it back. But the model may have its own biases, and it may summarize and present that in a way that reflects those biases. So it's definitely something to keep in mind when using these sorts of systems. And I just wanted to highlight one other use case is with our partners at Stanford. So Stanford used Data Commons to run predictive model to understand power grid resilience in the United States. So they looked at some extreme weather events, and they also looked at underground power infrastructure, and then the correlation between how did extreme weather events impact U.S. counties that had different percentages of extreme weather events. So they found kind of expectedly that for events like hurricanes and nor'easters, underground power was really helpful. But for other events like wildfires and earthquakes, underground power was helpful, but it wasn't as big of an impact. So with this use case, they were kind of running a research study on it, but it also helps direct like where should we invest in infrastructure? Like maybe in California, where wildfires and earthquakes are more of a concern, actually like above ground power is fine. And for the Northeast or like areas that are prone to hurricanes, like maybe it actually is worth the investment in some of this infrastructure. All right. Okay, we got a few more questions. What are some of the safeguards against this being polluted by AI-generated or biased data sets? There's not a workforce to check all sources for authority and provenance. I think that's kind of related to the previous question. You can correct me if I'm wrong, but with data commons, we spend a lot of effort in making sure that we're ingesting official data sets that are provided by international organizations, by official sources in federal agencies in respective countries. So we try to do our best to ensure that we're getting accurate, factual information in the system. We have we do have an open source offering of data commons where partners can ingest their own data. So that's kind of for data sets produced by nonprofits and NGOs, which is hopefully also verified by their own workflows, but it's just not something that we would vouch for or provide in our service. But again, there is always that risk of depending on what AI system you're using, it will inject its own bias into the system. But I think that's where having citations can help. If we link back to the original source, then it can let the user decide for themselves.
I think there's a question about, is it possible to get links to data sources used within summaries? I believe we do show the data sources.
Yeah.
All the sources of data are credited on the website.
Yeah. So with every data point that we have, it links back to the original source. With the description of the source, and a URL back to the source provider's website.
And then on Android Gemini app, why does export to docs no longer work?
Yeah, we'll have to probably connect you with someone on the Gemini team.
That's right.
But,
hopefully that was a blip and they fixed it back up.
Yeah.
Okay, and Nate has a question. Would an end user use the terminal?
So that's a great question, because like I mentioned, it is a bit more technical to jump right into the terminal. So basically, this MCP specification that I've mentioned, Google is working on adopting across the board. I can't exactly speak for the other teams, but I wouldn't be surprised if this MCP technology were available in the Gemini web app in the near future. It's available today on some of the other large AI platforms out there. So you could go to Claude, for example, and plug in the Data Commons MCP server and get a similar experience.
I think there's a question of data commons seeming to be more relevant to policymakers, but for researchers who tend to explore underlying causes, relationships, and implications rather than seeking straightforward facts or answers, how can data commons support researchers? I mean, data commons is meant for statistical tabular data. It is not for the sort of unstructured or imaging or other kinds of data that is of a more complex nature and requires its own type of analysis.
Yeah, and I'd also add that Data Commons is a great resource also for just finding out what data sets are available. So if a researcher has a hypothesis about a research question, and they just want to understand, well, hey, is there even data coverage for a specific type of data, or these sorts of questions I was asking about, what health data is even available for this country? It could be useful for that, and then at that point, the researcher can just download the data directly, do their own analysis. So it could be kind of more of that exploratory phase.
Is it possible to connect a small language model that is less likely to go astray, one that just knows the data and how to fetch and cite, but it doesn't try to be too clever?
Yeah, that's a great question, and that's actually something that our partners at the One campaign were very concerned with. You can imagine these AI systems where you go to a website, ask a question, and then it pulls back the data and gives you an answer. But I think that also raises some of the concerns that you're talking about. So with the One campaign's Financial Data Explorer, they made sure to only return the actual data sets and not try to answer the question. So if you ask, a question about compare health financing in two countries, it wouldn't actually answer the question. It would just point you at the data itself. So that's definitely possible to do. Yeah, go ahead.
Scott.
Hi folks, Scott from Sydney here. I'm thinking about your Stanford use case, because I'm looking at the people on the call, and so we have a whole bunch of people from Australian universities. We have folks from the National Science Agency, the Australian Research Data Commons. So and I'd love it if any of those people want to kind of ask a question of this nature. But what I'm really thinking about is the use case from their perspective. So I can see how the UN putting global data sets on the data commons makes a ton of sense. But I'm interested in the Stanford example, because there's an example where they're trying to answer a specific US problem by combining their data set in a specific domain with the global data sets. Because I guess what I'm really trying to figure out is, so let's say there's a Creative Commons data set related to an Australian issue, or it's Australian data. What is the value proposition or the use case in your minds for connecting that to the data commons, rather than just having it live in isolation on a public data set in Australia? I'd love anyone else's thoughts on that, but I'd love Priya and Dan, your thoughts as well.
Yeah, that's a great question. I think you do get a lot of value out of data commons if you kind of have a local data set that you can then join with something that we've got as well. Then it just saves you the work of having to ingest these other data sets and triage them and work with them locally. I think another benefit could be this AI integration. So if you take your own local data and you model it in data commons format, then you can run one of these local MCP servers and then start asking questions about your data kind of in natural language. So it can give you that too. Yeah, I think there's also opportunity to contribute back to the main data commons instance that Google hosts. So if admittedly, our coverage in the US is a lot better than it is in Australia for things like census data and those sorts of things. So if there's an Australian census data set that we just don't have, but it exists, you might end up loading locally to play around with. That might also be something that we're interested in ingesting too, just to kind of, again, save future researchers the work of doing the ingestion. We have a we have a whole 20-person data ingestion team that this is their whole job, kind of taking the stack of incoming data requests and normalizing them and getting them into the right format. So if there's a variable from the Australian census, we mark it as the same variable as something that might come from the US census. So you can kind of, with the understanding that they come from different data sources, do some kind of caveated comparisons of the different data points. Is that helpful, Scott?
Yeah, no, thank you. And I see some kind of similar questions coming in now, or from Christian anyway, so I'll...
Sure.
Christian, it says, which is Uncharted Waters, climate and agriculture tech, not-for-profit, create a lot of data monthly on subnational food production globally, resource use and trade. Would you advise us to create our own data commons, or would we be better off setting up a bespoke LLM? I don't know what SLM is. Chatbot from scratch. How sustainable or costly will this be? How much freedom do we have in limiting the type of queries or focusing the type of queries? Also, this is also from a cost perspective. I'm not sure which one is.
Let's read through it again.
Shall I try to explain a little bit?
Yeah,
more?
please. Yeah, thank you.
So, I mean, we're creating a lot of data, and obviously we are trying to figure out what's the best way to analyze that, because it's recurring data monthly. We have our processes, etc., but it's getting too much. Now, this is a new initiative, so I'm very curious. But I've seen other initiatives trying to bring together databases, and they sort of seem to fizzle out after a while. So before I put effort in making my own bespoke data commons private tool using our technology, I'm very curious to see whether you feel like for such an, I mean, not necessarily my thing, but how sustainable will it be? How much will it cost me? Is this a service that's for free? How long will you be providing it for free? Or would you say, okay, if you create such and such amount of data yourself, then better use and create your own system and just see what's useful for the general, in terms of using our general tool.
Right. Okay. Yeah. Thanks for the clarification. So yeah, just to talk a little bit about what it's like to host your own instance. So Data Commons is it's an open source project, and you host it yourself as an open source GCP or Google Cloud solution. So yeah, all the code is available freely online, but you do pay for the GCP resources that you use when hosting it. I think like a modest installation is on the order of a couple of $100 a month, and we're fully planning on supporting it for the foreseeable future. Yeah, and we've got a lot of support from our leadership, and also a lot of kind of customer buy-in from nonprofits, international organizations, some of the folks that Priya talked about. But no matter what, the code is open source, so you can run it in perpetuity on your own Google Cloud infrastructure.
And I think on our website, Nate, you're right, we do have detailed documentation about how to get started setting up your own custom data commons. And there's a link also there to, what the GCP pricing may be. I think, we're always happy to connect you with the right folks from the cloud team who can help you, sort of work through that and understand what pricing it may be. I presume it depends on the size of the data, and kind of the traffic that you anticipate. But we are happy to put you in touch with the right folks to kind of get a sense for how much it would cost.
Yeah, sure. We got. Oh, go ahead.
It's Chris Goodman from NGIS. We're a Google partner. We're working with a consortium of Australian universities to collect detailed health data, environmental data and census data. And we're using a custom data commons that we've only just started on this project, but I've found it quite well engineered, and I've been able to get a instance running in without too much trouble, and we're starting to ingest data. What you'll find with the data commons, the main data commons, is that it has only generic health information. What we're looking to do is put the sort of detailed information that at the moment only US information, for example, obesity, down to very low geographical areas is something you can do in the US, but that's data's not available in Australia. So we're finding it's quite a good platform to do. What we've been asked to do is very similar to what Data Commons' mission is, and so there's a really good alignment there. The question that I've got a lot of questions, but one is about whether there's any ability to import raster information such as images, for example, satellite imagery, and combine that with the time series and geographical information to do queries of that nature.
Well, thank you, Chris, and yeah. First of all, thanks for taking the time to explore data commons, and we're excited to work with you all. And to answer this specific question, right now we don't support raster information. We only support polygons with geospatial data. But me in particular, and everyone on the team really loves hearing out these customer use cases. So I would love to understand more what your use cases for raster data, and to see if it's something that we might be able to support.
Great.
Okay. We have another question about Bayesian analysis. So right now, data commons is more about normalizing the data and finding the data set you're interested in, and then pulling back the raw data. So any sort of kind of more sophisticated statistical analysis, you'd have to do on your own once you get the data out of the system. But I'll just caveat that by saying, whatever you can get an AI system or a large language model to do on your behalf, you might be able to finagle it with some prompt engineering. But yeah, that's but we don't currently support that sort of statistical analysis natively.
And from Alan on MCPs to set up.
Yeah. I might have to back up.
I think Alan's is more of a comment than a question.
Okay.
Yeah.
I'd like to ask how complex a query can, like, if you ask for, this variable plotted against that variable, it doesn't seem to have any trouble. But if you then want to look at, say, multiple scenarios, there seems to be a limit of how complex the queries are that it can support.
Yeah, and Chris, are you talking about the kind of datacommons.org website when you ask those sorts of comparison questions?
Yes.
Yeah, and right now we'll kind of support those sorts of comparison queries, like you said, for 1 to 2 variables, or to compare against each other, as long as the variables are the same, have matching units, and are variable in that way. But yeah, I think for the more sophisticated queries, you would have to download the data and do that sort of analysis on your own. That is something that we are working with and is on our roadmap for the next year. And the general approaches we're looking at are kind of looking at how do we leverage some of these AI systems to once they're grounded with the actual data that folks are looking for, how do we do some of these more exploratory things? But did you have anything in particular in mind that you were that you tried to do when asking questions that you weren't able to do, just so you can kind of take note of it?
A use case could be not just looking at the current data, but doing a scenario analysis. For example, if the state of Florida was to spend $1 billion putting power lines underground, how much less impact would a hurricane have?
Mm-hmm.
So you're sort of taking the data and then making a mitigation action.
Right. Yeah. I think our approach for that would again just be more around kind of exposing the right data and making sure that the all of the sourcing for that is correct and transparent. And then kind of leaving the kind of specific scenario analysis to you as the expert or to the researchers.
Okay, yeah. So you build something on top of that, and possibly that, like if I was to build a bespoke app that was for the state of Florida to measure the economic and value of undergrounding power, I would then want my app to call Data Commons, but it would know it wouldn't necessarily use a language model. It would use an API more directly to extract the data.
Right. And you might be able to call, and just to brainstorm on that use case, so you might be able to call Data Commons to kind of get up to date, like extreme weather event information, or kind of infrastructure spending data, or
Kind of break it down.
And use Data Commons as a way to get like up to date observations, but again, you might be doing the actual analysis on your end.
Yeah, okay, but I wouldn't need to use the natural language. Like once I know the exact data that I want, I can just extract that.
Yeah, exactly. Yeah. So there's all the kind of AI hooks I was talking about, but there's also just a REST API that you can use. Exactly. Once you have the variables, you can just call it and pull back observations.
Thank you.
All right, Dan and Priya, we're at time, so I just want to thank you both for giving us that overview, and hopefully people can see where their own use cases might be able to fit. You've got that final slide there, so any final words?
Thank you all so much. We'd love to hear from you. Please do try it out, check out our website, and send us feedback. We're always looking to learn and improve.
Yeah, thank you. And I'll second that. Any feedback you send us, we'll definitely read and reach back out to you all and please try it out and let us know.
Amazing. Thank you, and thank you everyone for all the good questions in the chat. Cheers. See you next time.
Thank you all. Bye.
Thanks.